All right, hi everyone. We're going to get back to our next session now. So I would like to introduce Shuchen Wang for moderating the EDGE discussion. Take it away.
Hi, hello everyone. Can you hear me?
Mm-hmm.
Sounds good.
Yeah, great. So let me share my Etherpad. Can you see my screen?
Yep.
Yeah. Hello everyone. Welcome to join this session, and it's about the edge computing. So today, this session we have several topics. First one, we will talk about the edge stories. And we encourage people attendees to talking about your story about the edge and any use cases you know about the edge. And please, if you talk about your story and you introduce yourself first and talking about which company you work with and why you look at the edge computing. And we can also talking about the typical use cases for different industries like telco, manufacturing, and financial banking, and others. And secondly, we will talking about the edge solution and what kind of software solutions you are using in the edge computing and how and why you use it, any feedback from them. And for example, do you use Starless to build it edge cloud? And do you use the Cube Edge or K3S and others? And also, what's the biggest challenge for building an edge cloud? Do you meet some security problems and any problems on building a networking? And do you have the reliability issues in the networking? And how do you resolve the performance for the storage? And also, we have some discussion about the edge footprints. Do you need a small footprint for the edge devices? How to manage them? How to use an IoT solution to manage them? And third, we can discuss about the relationship between the edge and 5G. As we know, the 5G is coming, and countries are building the 5G network, and the edge computing bring up the 5G, or the 5G bring up the edge computing. How can we build a Mac platform to let the application to use the advantage of the 5G? And last but not least, we will talk about the applications. Do you know about the application innovations on the edge? Do you know about how we can leverage AI capabilities on the edge side? So that is the 5 topics I bring up in today's. And if you have some good ideas, you can also write down your interesting points in the Etherpad. So let's get started from the edge story. First, I can introduce myself, and my name is Zhu Quan. I work for 99 Cloud. I also the member of Starless TSC. I'm working from since 2011. I'm work with I'm involved in the OpenStack community, and also from the 2 years ago, 3 years ago, I turned to the edge computing. I have knowledge on the enable the edge computing in the China here. Many telco customers, and also bring up the edge solution to the different industry in China here. And I would like to share my story about the edge first. And after that, I hope the participants, you can share yours. One interesting story about edge from my side is that in last year, we built up edge intelligence agriculture solution to help the farmers to improve the productivities to bring up the shrimp. And as you know, the shrimp it has to it requires high precision and the healthy balanced ecosystem for the water. So traditionally, they leverage the human experience to tuning the ecosystem for the shrimp. But we build up edge platform just beside the farms, and it collect the temperatures and the many other through the sensors to collect many metrics in real time near the farmers and tell the farmers how to provide a more safe and healthy environment to the animals. And automation is also building us tools to provide these services to the farmers. So the farmer no need to have very deep understanding about those animals' habits. They can just use those the system near the farmer in the edge to build up a healthy environment for them. By these ways, we can improve the productions for the farmers. So that's the one story from mine. And anyone want to share the story about edge from your side? Maybe you can talk about, I see someone is writing the HPC, and do you want to share?
I can do that. Was me typing in blue again.
Nice, Ron.
So from the HPC point of view, it's more that more and more they're getting very similar patterns of architecture, in the sense that you have experimental systems that are producing lots of data that need reducing, and then there tends to be a sort of federated network of clouds between different people in the center, if that makes sense. So it feels like a lot of the challenges that edge, sort of more mainstream edge, seems to hit, we're actually seeing in the scientific HPC kind of case as well.
And for the HPC, I guess for the edge side, you also build up consists of several servers, or just like the server form factor. It's not like those. It's not. It's built as maybe dozens of servers as an edge side, right?
It varies. It depends how big the equipment is. So, for example, in some ways you could look at the square kilometer array and then said, well, I guess what CERN does as an edge, in the sense that you have several experiments with reduction in a local compute cluster, which may be racks of servers, but then that has a data stream that then goes out to the more, pushes it out to several data centers that then do the analysis. So you effectively, you kind of, in the same kind of way that you're reducing the signals down to send it to the central place to do the processing.
Do you install the like the accelerators in those servers? I guess maybe have the FPGA or GPU kind of devices, right?
Yes, it's a simple answer. It depends on the what processing needs to be done. But if, for example, you're doing FFTs and things on signals to get the data out, then GPUs are quite good at that. It varies.
Yeah, I also see the +1 in the telco. I think right now telco is one of the major 2+1. The telco is building the 5G infrastructure, and edge cloud infrastructure is critical to the telco industry to build up the 5G. As I know, in China, like the China Telecom, China Unicom, and CMCC, they all start to build an edge platform. They will have their own standards, or some of them may leverage like the ETSI reference architecture to build up the edge. So someone want to share about the stories from telco?
I can share a little. This is Chris. I mean, yeah, I added the first two there. You know, radio software, it's deployed close to the antenna. It needs to be close to the antenna. And then you of course end up with lots and lots of sites, small sites, which are deployed close to the antenna, where of course you have, you know, cloud technologies coming out. I mean, this is one area where there are a lot of different solutions, because being close to the antenna can require a number of different hardware form factors, which then require a number of different software solutions in order to make sure that that software is manageable and running on site. So that's a clear thing, a driver for the telco industry. And I think what we see is that there are a number of solutions enabling virtualization and virtual software management and lifecycle solutions based on virtual software coming out in telco networks to address each of these site types. And that, I think, is an asset that the telco operators in the telco industry will have moving forward. So they will have, you know, this very fluid and very dynamic infrastructure working in a number of different deployment styles. I think that's something that we should be looking at, and we should be trying to understand. Okay, what does this provide as far as a platform for innovation when it comes to, as you were talking about, 5G services, where the softwares that are emerging that need to be close to device are starting to become available. How do we make sure that they can land and be used in the right way?
Yeah. Thanks, Chris. It's a very interactive session right now. I'm Ahmed, working for SSE. We have a lot of use cases right now. Try to develop in Saudi Telecom as a edge. One of them, the PRAN use case right now. We have a lot of challenges to implement this very digital signal processing as the edge. We start looking for some FPGAs to be implemented as a telco. As well as we have some CDN. Sorry, I'm echo myself.
So Prakash here. Yeah, following on what Chris said and the other gentleman from Saudi, the issue of what you call having a compute unit closer to the antenna, like RU, we call radio unit or remote radio head types closer to that. Essentially, because the traffic that comes both uplink and downlink at that cell site, whether it is a small cell or the macro cell, needs to go towards or uses CPRI, what you call common public radio interface. So you can say radio over the optical. And once that's done, that means you can actually keep a little distance. And currently the standards are like you can go up to 75 kilometer, 675 to 120 kilometer. So therefore the hoteling, we call it BBUs, that can be the, that's what is going on in the transport area. And then essentially that goes to the data center, which is our edge data center. So the play is between the BBU, the central unit. You split the BBU into RU and the CU,
Yeah.
the centralized unit and the distributed unit, and then the data center is somewhere in there in the centralized unit, or it can be in the in between. That is the front hall or the mid hall, which we call it. So the edge can be the more important aspect for edge computing is the data center and the interfaces connecting it, so that we can build specific capability which are very which can be for multiple radio units, or it could be for multiple distributed units, or it could be centralized. So that's where the whole of this real time, non-real time, and those aspects come into picture. So essentially one thing to remember is it depends on how much of aggregation we do, so much of computing will need capability there.
Yes. Also, I heard an idea is that the edge computing actually is combining like the IT and CT together, because as cloud computing is more focused on like the IT infrastructure, but like the edge computing, it will interface with like the BBUC such as CT technology. So actually edge computing also is a combination of the IT and CT. And so anyone want to share other stories about in other industry? I see some discussion on the manufacturing. Someone want to talk about the manufacturing?
Hi, Shushan, that was me again. Oh, someone else is speaking?
Yeah, okay. I'm Steve from Nana Cloud, and today I will share a Starlink X use case. The project is involved with Intel and China Tower. China Tower provide a data center. Intel provides servers and the NUC, which is a small server machine, and the Nana Cloud deploys Starlink X on servers and the NUC. China Tower has 2 million towers and 1 million small data center. China Tower plans to open up the resources of the small data center to OTT manufacturers such as iQIYI and Thunder, which is a Chinese company. It has already done technical tests with OTT manufacturers. Empowering infrastructure with edge computing is a key task for China Tower this year. The test, promotion, and technology selection are carried out by the technology department of China Tower, Beijing headquarters. And the China Tower provincial company is responsible for promoting the business. China Tower Shanghai company will be the first to deploy Starlink X. The Starlink X edge computing technology provided by Nana Cloud basically meets the need of China Tower, involving center edge architecture, security strategy, container platform, unified orchestration, and remote management, monitoring, etc. China Tower starts with CDN business and use lightweight equipment, and the NUC equipment provided by Intel mainly carries its CDN business and use container technology to achieve the isolation of different CDN vendors. The test mainly used the small data center of the China Tower Shanghai company as the hardware environment, and each provincial company deploys 3 to 5 units for technical verification. To sum up, these tests can scale out to the whole country if the result of China Tower Shanghai company test is work out. So this is the story I meet in my project. So is someone have some questions?
Yeah, I heard just is Chris, you want to share yours or?
No, I was actually going to ask a question. How many sites are in the trial that are ongoing with the Starlink X solution?
The first test is involved 2 small data center, and we have 6 servers in the environment, and we deploy one Starlink X and 2 servers for central cloud and 4 servers for edge cloud.
Cool.
Thanks.
Cool. Yeah. That's exciting.
Yeah, it's a great example to.
Yeah, it's a great start, I think.
Yes. Yes, and I think it's slightly different because I made the comment that I saw a lot of manufacturing use cases, for instance. These tend to be quite bespoke. I think is the word I use. Like they're built for purpose. There tends to be, a mining operation or a particular manufacturing operation, and then a collection of people get together and solve that edge use case. And I think what we need to start to do, I think, is actually reach out to those people and say, okay, share the things that you can share about that, because while most of these are bespoke, one can imagine there is a lot of commonality and a lot of things that we can bring out into common use cases that can help on, for instance, the manufacturing edge or whatever. It seems like an area that is extremely active today, but there's not so much coordination, especially on that infrastructure layer and the common pieces that kind of need to fall into place.
Yeah, I agree. For the manufacturing, actually, each factory, they they would like to see the solutions to resolve their pain points. So they actually the infrastructure, there's one part, and the applications above it just more important to the end users. So I think the edge combined with AI application is more popular for the manufacturing. Just like as I know, in the cities around Shanghai, they they have a festival or many other or making the screen factory. They would like to see, for example, like the fault detection algorithm AI application combined with the edge infrastructure to improve their productivities.
Yeah, Prakash here. Yeah, I would like to add here something interesting. And the interesting part is like I've been working with IEEE, some of the groups, and there is some group called INGR with what they call deployment group, and they told me that the boxes at the poles, which is used for the traffic control, they need to be specifically secure. Yeah, they need to be secure. The boxes means it's an edge server, right? At the end of the day, smart city applications tend to use some kind of a form factor which needs to be sturdy for both the power availability as well as security aspects. It needs to be hardened. So they have some specification, at least in the US, which need to be complied with so that it is secure. At the same time, traffic can be managed. So it's a kind of a very similar to what we have in vehicle to vehicle or vehicle to the infrastructure, like
similar to some
very similar to platooning, like platooning or onboard devices to manage the vehicle to infrastructure as well as infrastructure for the traffic pattern. And so intelligent transportation system application I would put at the edge.
Yeah, that's also for small cell. Used to be called Muni Wi-Fi, but a lot of the 5G stuff, the densification stuff requires that ruggedized footprint as well.
That's correct.
Yeah, it's interesting. It's kind of I also see these use cases in China here is similar to some gateway, have some security functionalities and some networking together, and it could be controlled from the central. Yeah, I think we have share many use stories, and also if you want to know more about the use stories from different industries, I encourage you to read the latest Edge Computing Group white paper. I put the link in the Etherpad. You can just click and take a look at it. There are many use cases, and you will find someone you're interested. And next,
that brings an interesting question. How do you deal with the energy? Are you using DC, more popular in edges, or is it more of a AC in terms of power?
I guess both.
Any advantage of using DC over AC power, or
I think the power and save energy and it's different, but actually here I see the both cases.
I think the telcos prefer DC just because their infrastructure is typically DC. So
no, but does it mean that you can get the solar power on the field and have a converter, or you use directly the DC power from the solar?
You are asking?
Yeah, I'm asking, in China Mobile, are you finding solar energy being used as part of the edge?
Many of the points they are used just AC, and some pilot they are trying to use DC right now, but both cases have also existing.
Okay, thanks for that.
Mm-hmm.
So I have another question. Do you see much power over Ethernet on the edge requirements? It's just a general question for the group.
You mean can you say that again? The DC more general, or?
Yeah, just is there a use case for using PoE at the edge, power over Ethernet?
PLE, I guess.
Yeah, PoE. Yeah, I'll get some more.
PoE is mostly on the switches, right?
Yes.
They are on the switches, not on the host servers, right?
No, not on the servers, but on the switches, right?
Mm-hmm.
Yeah, maybe for video surveillance use cases that we need to
potentially
bring up the camera.
What about the VRANs?
VRANs actually
VRANs, it will be hosted on the COTS, commodity of the shelf server. So there is no need for there is no PoE on the switch as far as I know. The server, sorry.
Well, I'm asking if there's a use case for it.
For the VRAM, right? Actually,
right.
There are a lot of pilots in the VRAM, CRAM, the kind of pilots, but in right now the 5G constructions, I see some cases in the pilot right now.
Mm-hmm.
As you know, the 5G is still not in production right now yet. It's a lot of architecture is S8, and building a lot. It's still building the SA pilot, and I guess for this SA architecture go to production, it will be the late Q3 or Q4.
Right. Okay. Because I could also see it for IoT devices as well. That it would be useful.
Okay. Any more questions? Let's move on. Next, we will discuss about the edge solutions. So we just mentioned. I heard someone talking about the Starlink X. As you know, Starlink X just get confirmed as a confirmed project in OpenStack. And actually, if you use Starlink X, it only resolve part of problems in the whole edge. And Edge has more than has a lot of problems we need to resolve, and Starlink was providing the infrastructure And if we want a better like the orchestration layer or or connect to the like the OSS, DSS to the that kind of system of telco, we also need to build other systems to combine them. And also, if you need to have some like the DNS handling or some API gateway functions, then we need to combine with other solutions. So anyone want to share about how do you use the software or solutions to build up your edge solutions?
Yeah, for the edge is very special requirements, and we always mention here that it's very small footprint. So regarding the architecture, I will refer to the white papers that you mentioned right now in terms of solid, two solid architecture that can be implemented right now in the network in terms of distributed compute nodes or centralized controllers. So these two approaches are, and architecture can totally fit in the edge in terms of very small footprints that can be extended into any numbers with centralized control plane and just remote compute that can fit the use cases that we mentioned right now in terms of telco and non-telco use cases.
The small footprint is like ARM devices or x86.
Solution again?
Yeah, I mean, you just mentioned the small footprint devices. What architecture it is like the ARM devices or x86 devices?
Yeah, I could speak on that. Yeah, we're using x86, but we have looked at ARM devices. We would like to, but the software doesn't really support them.
Oh.
Yeah.
So why you consider the ARM devices? Because the
Cheaper.
power? Or...
Yeah.
Okay.
Cheaper, smaller footprint. Yeah.
Mm-hmm.
Yeah, cost and power, yeah.
Bev, do you consider to like the data center service replace ARM devices?
Good question. I don't know.
Yeah, actually,
it's cheaper.
Especially with Apple switching to ARM. Yes, sure, why not?
Actually, as I know, in China, many big telco company or many other company, they try to switch to ARM, but actually a lot of cases are just pilot cases, and evaluate the performance of ARM and the comparabilities of ARM devices, like the software, but it is evolving, I guess.
It's very much evolving. Yeah, yeah. I was the ARM folks. I attended a presentation. Was it last year? What they're doing right now, and it looked pretty good. But the software is still lagging. Right? So,
yeah, is there people from ARM here to attend this session?
Yeah, I don't know.
Linaro is there, if you obviously, but still it requires a lot of hand-holding.
Yeah, I'm not saying anything against ARM.
Yeah, you're saying the truth.
Yeah, just saying the truth.
Yeah, understand. Yeah.
Just a question: which software do we see as lagging? Is it the tooling? I mean, the OS is there, of course, but is it the tooling or the applications?
The applications.
Because they're not just Linux native, right? They build against particular CPU architecture. Yeah,
exactly.
Yeah, I see someone draw.
Cloud native. Okay, sorry, Sean.
Yeah, sorry, I just read the message. Someone draw questions in the chat. He want to learn more about the telcos and internet service providers design. I suggest maybe you can read the white paper from the Edge Working Group. We have 2 white papers. The first one is, name is extend the data centers. It will explain you they have some descriptions about how telco build up the edge platform and what the edge cloud computing is. And the second, he will talking about the architecture designs and testing, and you can take a look at it.
Well, I actually that brings up a question, because the person who wrote the note said data centers, and I know there's a lot of confusion in the edge world about what is edge. And I personally, I break it into two pieces. There's the edge that's a couple racks, and then there's the edge that's a couple boxes, and the requirements for the two are radically different.
Yeah. I think from my understanding, I can treat different from the the network latency. There are different edge sites, like the access layers or aggregate layers or the data center layers. So different edge sites, you have different scale, and IoT may be the end for the edge sites. It's just small boxes.
Right.
Could be
right. Those are the gateway, the IoT gateways.
Yeah.
Which are small boxes. Yeah.
Yeah. And also, I see someone's write the face recognition. So, do you want to share?
Yes. Hello, my name is Chen Yu from 99 Cloud. Today I will go sharing an edge solution that combines Starlink X infrastructure and face recognition. As we know, the Starlink X is a complete cloud infrastructure software stack for edge used by the most demanding application. It is good at managing distributed cloud. In this case, I use some Starlink X feature like a scalable, small footprint, ultra low latency. When it goes to face recognition, we have to train the model by neural network and other else. We train an AI model in a data center with a bunch of GPU and cost a lot of power. Cost a lot of power. In this case, the data center is the central cloud. First, we prepare a central cloud which has some management service like configuration management, host management, fault management, and software management. Those will support central cloud to deploy and management edge cloud. Second, we deploy an OpenStack infrastructure on edge cloud. The OpenStack service will create some virtual machine to handle its own project. In my case, we prepare an image with well-training face recognition model, and OpenStack will use this image to create a virtual machine. As the face recognition image do its part, central cloud can collect the data from the edge cloud to do the analyze and research. Besides, we can do the image upgrading from version 1 to version 2.0 in the central cloud and push this new image to the edge cloud. The total solution is what I sharing above, and the most benefit is we do the hard job in the data center, like training model, like analyzing in the data sorting. And after we build a new or make a new training model, we just make it an image and push to the edge cloud. This will make the low latency. And the edge cloud, actually the face recognition, we need a camera. The camera can be put on some IoT box like a Raspberry Pi or some small computer. And it is even easily to do some flexible and scalable deployment. For example, if we deploy on a industry, and based on each scenario, we can put more or less the device. Just depend on what we want. Thanks for your hearing. Thanks for your attention.
Yeah, this is interesting. It combined with the Raspberry Pi. And okay, let's go on. For the biggest check. Go ahead.
Is this 99 cloud person Chengtai, right? Do you use this for security systems for identifying the individual, or is it more of a experimental at this stage?
Excuse me. You say that I use the identification
Yeah.
management
Is it for the identification of the person, or is it more like experimental right now?
Or just put it on to recognize the person's face? Yes.
Yep. Prakash here. Yeah. Oh, so okay. So you are identifying the faces you're seeing. Okay. Thank you.
Thanks.
So since you're using the pre-built image, so the image is the one which also includes the programming of the GPU for that, or using like Cyborg or some other way of configure the flows through the GPU?
It doesn't matter. It just as we build a training model, training our own fixed face recognition model, using the GPU is more convenient, but we can't put a GPU or other more high performance equipment on the edge cloud. It should be done in a central cloud.
I understand that. It's more a question of how do you do the separation of the application from the underlying platform, and that's the question. Do you is a part of the application you configure the hardware GPU for that, or you use some programmatic way such that platform and application are independent from each other?
Oh, okay, I understand. I will think later, and I will
Maybe
respond
look
as soon
at
as possible.
are you using something like OpenVINO library from Intel for the hardware? If you are using Intel, if not, then any other library specific?
No.
I guess this application leverage the OpenVINO, right?
Yes. Use the
Yes, it's for application.
NeuroStick and use the OpenVINO.
Okay, that gives a clue how you're
So
doing.
so by the OpenVINO can adapt to different platform to use it, the accelerator also, right?
Correct. But you do it programmatically instead of the hardwiring. That was the question.
Sure, that answers.
Yep.
So the next question is, what's the biggest challenge for building an edge cloud? I think the networking is all three have 1+1, and do you want to share? Anyone want to talk about like the security here?
Yeah, that was me that put all those 1+s. So security is because you don't always have control over that edge, right? If it's out of a data center, if it's on a light pole, we talked earlier about ruggedized. Security is also an issue as well. You need to be able to, if somebody gets onto the box because they have physical access, that they can't do anything. So there's a lot of dimensions to the security needs. Storage, of course, because again, there's a limited amount of storage. So you also, I know at the PTG a couple weeks ago, what came up was a long discussion around persistent storage, because again, you don't have, if you lose network access to the device, you need to be able to restart it. So you need some kind of persistent storage. It can't all be in memory. And then there's also a lot of use cases for moving storage to have stuff out, in storage, particularly CDN is an example where you want to actually have data stored out at the edge. And again, not in memory. And of course, we've already talked about the small footprint. So.
Great, and I would like to share about the networking. As I said, the telco building the 5G and the MEC platform, they have to connect to the 5G-C. So the networking is very complicated. For example, like the UE, they have to connect to different the UE has to go through the different controlled commands and connect to the MEC, the data flow going through the MEC platform and go back to the networking, and how the MEC platform connect to the UPF, and how how those different components building the network topology, and also
and
how to monitor. Yes, and the network slicing, that is very complicated. And different telco and different companies have different strategy, and they have different catalog for the customer and target industry that's different. So different needs for them. So I guess the networking is, I think it's the biggest challenge for me.
Yeah. In terms of, I'm just need to emphasize here regarding, we need to be more conservative about the terminologies that we use. I'm always mentioned in many, I work with this in CMTT, Edge Workstream. So we try to put it in, not every edge deployment is a MEC or MEC. So when we use MEC or MEC, it is ETSI MEC architecture with some solid architecture and some defined APIs. For the edge itself, for sure, the WAN latency, one of the aspects as the challenges regarding the networking inside the edge pod or POP. One of the most challenging parts, especially if we use multiple use cases, maybe vRAN and CDNs and AR, VR, gaming, all this stuff, and we need to have certain service chain use case across multiple functions. So we need to extend maybe some SDN stuff at the edge, so which I believe is very complicated. And if we're looking for more containers, container infrastructure at the edge, and we need to extend the container network interface to be extended to SDN or something like that as well, it makes our life more complicated. So the edge networking as the edge is very challenging points that we need to take care about this challenges.
So that brings me to China Mobile did present, Linglideng did present in the ONAP the network slicing, and they focused on the core side of it and core transport and the radio side. But I never heard about that edge being included there, but that's because it will probably be in between the transports if I push it that way.
Yeah,
either side of it. So
I think
yeah. Go ahead.
Yeah, thanks. I think I saw this slide in attend this session maybe. The point here regarding ONAP, we can onboard end-to-end service touching the transport, touching the edge, touching the core, but to extend or to make networking extending from the core to the edge, maybe it is not such easy task, as that need a lot of implication. Especially we are looking for again small footprint, maybe cloud container infrastructure should be deployed at the edge.
as one of the points that we wrote it here as a Q3S or Cube Edge. This is container infrastructure based. So if we need to have more networking facilities and power of networking, it would be this platform it will be challenging to us to achieve what we're looking for.
Yeah, but Cube Edge is definitely a good work done for the edge deployment. Essentially, we need, if we have somebody talking about Cube Edge, we would appreciate.
Cube Edge is considered a seed project for CNCF. It's under CNCF consortium. This seed is invented from folks from Hawaii, and we have discussion during couple of activities during LF Edge and all this stuff. They have blueprint with Acrene right now for Cube Edge, Acrene blueprint. But personally believe it is not commercial or telco grade deployment that we as I'm presenting telco here. So for the telco deployment, I think there is a lot of challenges to make Cube Edge as one of de factos or one of architectures that we can depend on it as such this time. Yeah, maybe down the road can be evolved more and more. But right now, I am assessing it, and it's not capable to fulfill telco grade applications that we are looking for as Edge. It's my insights.
So it's a use case
But
issue. You need
Sorry?
to identify the right. You need to identify the right use case. You're saying.
Yes. And by the way, the Edge concept or the Edge story, it is as I'm always mention that it is use case driven, and no one size fits all. So whatever use cases that you can put Cube Edge, you can put the Q3S. Distributed architecture, centralized architecture, all in one, Starling X. So you need to figure the use case first, and the vertical that match this use case, and looking for the infrastructure that can achieve this use case for sure with low cost, and avoid the challenges that we list here in terms of networking, storage requirements, image handling. All this stuff.
So it is a functional capability, right? Like you have for the video, you have OpenVINO. Similarly, we need some software for the sound, text, and those kinds of media recognition and encryption, decryption that are required at the edge to either to do it at the edge or to defer it to the cloud, like you mentioned about the VM in the, not you, but 99 Cloud mentioned. So I think Acreno has got hundreds, not hundreds, at least 20, 25 blueprints. And I don't see all of them being active now.
Yes.
And only some of them have spanned out because they have real use cases.
No, there is a lot of.
Yeah, go ahead.
Yeah, I think there's active. Yeah, there's active blueprint under Acreno, like network cloud, which is hosted by AT&T, and there's a lot of networking part covering in network cloud blueprint. Right now, we work with the Acreno team in terms of 5G edge use cases and some sort of PaaS platform as a service, and how can we expose 3GPP SA6 APIs to external developers to start to develop certain use cases. Personally working with Telco Edge Cloud under GSMA, so we have some sort of alignment to utilize this effort as well. So I will repeat it. It is use case driven approach. Whatever use case you have in your hands and you need to implement, you will find the way to implement it.
Yeah, but none of them still haven't been a killer application in the edge. That's the challenge we have. We don't have a killer application as such. It's all distributed.
Yeah, we don't know the killer application because 5G is not it's just coming. It's not not built, and just like we don't know the killer application for 4G is not actually happening. So maybe we can discuss what's the application for 5G and how to optimize for that.
Based on the stats, it is the video which is the killer. But still, video has got so many streaming applications. We really can't get to one specific video use case, which will make it.
Yes, the short video app is very popular right now in 4G, but I think like the AR VR application may be more popular for 5G. Right now, the AR VR require more low latency and high bandwidth, which the 4G network cannot provide it. And if we have get better experience in AR VR, as we all know, it requires lower than 20 milliseconds. So I think that will be more is a very popular application in 5G networking, but I don't know if it's the killer application for 5G. That's my point of view.
Is gaming not so popular? AR VR is one, but are the gaming like we had yesterday present gaming for the large scale applications by Bizarre? That was the LA company. Do you see gaming in China picking up a lot?
Yeah, I think gaming is should be one of them, and because as we all know, the gaming has huge customer, huge users, especially for the young teenagers, and beside that, I also see like the sports or entertainment is very popular, including gaming and short videos and sports, like the sports that the AR VR give the immersive experience for the people, like you watch like the basketball sports or some F1 games. They will have better experience. They have to leverage the 5G network and the MEC platform to implement that.
Interesting.
Yeah, and from my personal side as well, why we always mention scalar application. Right now, the telco right now looking for some monetization of the edge. So if we have a very business case and use case like gaming, and we can build this edge and start to cooperate with any gaming company, EA or something like that, and we try as a telco monetize this edge deployment, it will win-win situation. There is no it is not about killing application. We can work in win-win situation, avoid killing actions, and we can work together.
Yeah, I was quite curious about what was the people from like the North America or Europe. What's the point of view about the edge application? Can someone answer that?
From North America, what we saw is gaming is definitely, like yesterday it was pointed out, gaming is one of the more popular applications, especially with the younger kids. And from other use cases, is one of them is utility, like metering, net metering, both power as well as meter reading for the water supply and various other utilities. Those are really good ones as we see in North America.
Great. Yeah, I see the time is up, and thank you everyone to join this session. And I think this is today. Thank you.
Thank you.
Thank you, guys.
Thank you for managing.
Thank you, guys.
Thank you so much.
Yeah, thank you so much, Shushan. That was great.